did this the last time I was on one. But hey everyone, thanks for joining. My name is Rob Simon, and I'm the practice lead here over mobile and hardware security. And then joining me, I also have our principal security consultant, Drew Kirkpatrick, and then our senior security consultant, Whitney Phillips. So figured we get a chance to look at a lot of different mobile applications for a lot of different clients, and that kind of puts us in a unique perspective where we get to see lots of different things, lots of technologies, lots of different backends, lots of front end on those as well. Um, so it gives us a little bit of a perspective in terms of things that we see, types of vulnerabilities that we see, um, kind of areas of focus, issues that we see that come up often. So we figured it might be nice to do a webinar on mobile security, just so if anyone has any questions or wants to talk about kind of the testing techniques or some of the vulnerabilities or issues that we're seeing or um, anything along those lines, that we could do that. Um, so I guess we could start off with just, are there any questions to get started? Or do we want to just start talking about kind of some of the processes and things that we use when we do testing?
There actually is a question posted already. Let me see. So anonymous attendee asked, what various methods do we use to obtain the mobile applications during engagements? So I guess that's more of a question on delivery. Um, Obviously, some of our clients have us testing production apps, so we're grabbing them off the Play Store or the App Store. A lot of times we're using something like Test Flight or a beta program where we're kind of submitted into the program. But sometimes we have clients that just give us the APK or the IPA file, which I really like because then we can sideload it. Kind of opens up some of our flexibility, especially on the iOS side. But I can let Rob talk a little bit more about that. But there's a number of ways, and it just really depends on how the client feels comfortable delivering their application to us.
Yeah, us personally, we're pretty flexible on that, but there's many ways to do it, right? Like test flight. There's other third-party ways to do it, and then just sending it directly. Um, but there's many ways to do that. We've also had, phones delivered with applications pre-installed. It can be kind of limiting doing it that way as well. But we're typically pretty open in terms of what we can do with that. Um, One of the things that we get asked a lot too is about the devices that we test on or how we do testing. Um, so we test on rooted or jailbroken devices. We like to try to test on physical devices where possible, but we also have the capability of testing on virtual devices. Sometimes it's a little bit trickier with iOS. There is a service called Corellium that's actually kind of nice that we use on the iOS side as well, though, which lets us virtualize iOS devices and then jailbreak on any version. Um, if you've ever done testing on mobile, you'll know that it's a lot easier on Android for us to get a device where we can root that and be on the latest version. iOS can sometimes be a little trickier just because that's kind of a moving target. Um, Sometimes we have to get older hardware that still has vulnerabilities, or you might get stuck on a version where there isn't vulnerability available yet. Um, but that's one thing that we deal with a lot. Trying to obtain devices and obtain ways just to get the testing going. But there's lots of options that we have there that keeps things pretty flexible. Um, and then from there, I know we do get asked a lot too on, since we test on rooted and jailbroken devices, we do get a lot of questions on should we do root and jailbreak detection in the application. So that's something that I just wanted to touch on a little bit because I know I see that question come up a lot, and I think people sometimes misunderstand the best time to use that. Um, so we test a lot of different types of applications like mobile banking, MDM, but also just casual applications or like food ordering things. Where you're just kind of placing your order for some food and going to pick that up. Um, and I think it doesn't make sense, I think, to use that in every type of application, but some I do think it makes sense as a control. So, for instance, the ones that really make the most sense, in my opinion, are MDM, online applications or mobile games like that, where you're trying to prevent cheating. So, trying to lock the application down, make it a little bit harder to tamper with things or mess with things. Especially MDM, where you're trying to ensure that the applications that are getting installed are installed on a device that is secure, that doesn't have any vulnerabilities open, that isn't loosening security controls intentionally by doing jailbreaking. So that in those cases makes sense because we're trying to make sure that the device itself is locked down, that we're operating in a more secure environment. But where it doesn't make sense, where I see it used as a control sometimes, is applications that are, say, not not doing something in the best way. So maybe instead of using something like a keychain or the key store for storing sensitive information, maybe they're using hard-coded secrets, hard-coded encryption keys. And the idea is that they would use, root or jailbreak detection and prevention to try to prevent someone from gaining access to the application, and then looking at those secrets or finding them. So that's one thing that I see asked a lot. Drew or Whitney, I don't know if you have anything you want to add on that.
Well, we can circle. It looks like we have some more questions in the chat, and we can go back to. It looks like somebody had asked, how often do you test apps that are in the app Play Store versus not? And I would have to say for me, it's probably 50-50, and it's just dependent upon the client who provides it. Now, I know in the past when I was doing testing for a different company, I would not probably get my apps from the Play Store just to keep myself anonymous. There's other third-party hosted locations that I would pull the APK files and the IPA files, and then, um, but I would have to say for our job specifically, it's about 50-50. I don't know. What do you guys think?
I would agree with that. It's about 50-50 for me.
Okay. Then it also looks like moving back up to the top. So Ian S said, how has iOS app tracking transparency framework affected your testing methodology? Good question. Rob?
Uh, to be honest,
I don't
I'm
know.
yeah, I don't know if we've really looked into that much. Um, but another question that we had in there was common reversing techniques for Smalley code. I'm kind of I'm interested in that one in terms of what you mean by the common reversing techniques for Smalley code. So I mean, we've done some reverse engineering on mobile applications. I would say we don't tend to always do a lot of reverse engineering. It just depends. Most of the time, we're focused on kind of getting onto the application, starting to get traffic proxying, and then looking at kind of the back end. We really only dig into that level sometimes when we have like special cases where we're trying to kind of really dig into the code and see what's going on with something. Maybe especially around like devices using like Bluetooth or NFC, and then we want to really dig in to see like maybe how codes are being generated or something like that. Um, so for like Smalley code, most of the time we don't go down to the Smalley code level. We would do like a decompiler that would turn the application back into a jar file and then look at it from the Java aspect. The only time we really get down into the Smalley code would be if the application is obfuscated or maybe because of new language features in the decompilers we're using, they don't decompile back to good usable Java code. So we might drop down into the Smalley code to take a look at that. But that becomes a little bit time consuming. Um, so at that point, it kind of becomes, unless we're really focused on something, um, reading through the Smalley code isn't usually the best use of our time, but it's definitely something that we've used before.
I mean, so there's a big benefit to Smalley in that you can do the edits, right? I personally find that if I want to change the behavior of an application, I'm not trying to patch the binary so it runs that modification every time. So what I'll do is I'll like lift it up with like JADX, right? And I'll be able to review the source code in a readable form. I can't make edits to it, but that gives me enough knowledge to use Frida to change the behavior of the application on the fly. It's not the same as a Smalley patch, but it's a lot faster in my mind to do it that way, to use Frida to make the edits runtime and just figure out what you need to change by using something like JetX personally. I haven't looked at Smalley in quite a while at this point because the other tools have gotten me where I needed to be.
So we got a question on what iOS phone models do you currently recommend for jailbreaking and testing purposes, especially with regards to apps obtained through the App Store rather than a sideloaded IPA? And then and on top of that, how do you evade jailbreak detection on iOS and Android? So that's a good question. The devices, that's always a moving target. So I guess whatever I say today could change tomorrow. At the moment, the kind of the checkmate vulnerability that came out for the iOS devices, that's kind of the biggest thing. So at the moment, we kind of look for trying to remember the name of the websites. There's a couple websites that we use. I don't know, Drew or Whitney, if you can remember, where they kind of give you like all of the device models and they give you the information as to which ones. I have it bookmarked. I just can't remember the
The
name of it off the
wiki,
top of my head.
the iPhone wiki, I thought. And
Yeah.
it gives you
Um,
your iOS version and
I'll try to
I can
do a
pull
quick
that up.
lookup of that too, just so we can share that. But there's websites out there that will give you some information as to all of the different the iOS device models, what the latest version of a jailbreakable iOS version you can have, and then the other thing I'll look for is what is the absolute latest version of iOS that device supports. So honestly, the process on iOS becomes looking through that and trying to find a recent device. If let's say the latest that it can go to is 16, and that's something that we need, but maybe 17 is the latest iOS in general, then we'll try to find that device so we can say, we know if we get this, if we do an update, it's not going to go to 17 because 16 was the latest supported for this device. Um, and then we know that that's jailbreakable. So sometimes that can become a pain. But honestly, that's really worked for us this whole time. We always have these scares where the next version comes out and we're worried about what happens when we need to get the latest iOS version and do testing. But the way that we deal with that sometimes, like I said, we have a combination of things. One is Corellium. We can use that to virtualize iOS devices, and for the most part, that does okay. That does have the drawback that we can't get things through the App Store. They do have, I think, in some of their paid plans, some features where, and I've not tested or tried this yet, but you should be able to say, take a device that's not jailbroken, get the app from the App Store, load it on there, make a backup, restore the backup onto their platform, and then be able to do your testing from there. So that's one option. Um, Another one, really, when it comes to having to get it through the App Store, though, we are kind of tied on that. We do push, we ask to get a copy of it some other means if we can provide an IPA. Otherwise, we can still try to move forward and do some testing. It's just going to be very limited, without a jailbreak or without being able to patch the application, which is another method we can use without jailbreaking. We can patch the application to have what's called a free to gadget that gives us kind of similar to being jailbroken, but we just see like that application's local data directory and things like that. But without being able to do that, it kind of limits us to trying to sniff traffic, but not installing the certificates, but not being able to force the application to trust them. So it really does become kind of a limited test. I know Drew's spent a lot of time with messing with like backups on those situations, where we have things that absolutely require the latest iOS version. We don't have a jailbreak. We have to get it off the App Store. So the way that we deal with it is just kind of let clients know ahead of time, like in these situations, this is very limited. These are some of the things that we can do, and just kind of make sure there's an understanding moving forward with that. I don't know if you guys want to touch on that a little bit more.
It definitely limits you when you don't have a jailbroken or a device. Uh, and you do kind of you're scraping for whatever you can find. So you really try to work with your clients to get into a scenario where you can test it more effectively with a rooted or jailbroken device. That can be kind of hard, especially if there's like an MDM involved, and they can't make exceptions and policies. I've had clients where I spent a day and a half on the phone trying to get a jailbroken iPad pass their MDM detections to do the assessment. And for them, it was worth to spend a day and a half before the engagement to work through that and create all those custom policies. And it worked out very well for them to do that. But not every client's going to be able to do that. So in that case, you just have to let them know up front that what the limitations are going to be. See if you can find sensitive data in backups is certainly one thing we look at. That's more of an issue for iOS. You can still create iOS local backups. Um, Android, that's becoming less of a thing. ADB backups being deprecated, things like that. Like Google's really going to kind of cloud only backups. So even that's becoming less of a quote unquote attack vector. So it can be very challenging if you can't get in there with a rooted device. So.
And I think the second part of that question was how we deal with jailbreak and root detection. And the question was, do we use Magisk? So on the Android side, yes, we do use Magisk. There's different builds of Magisk. There's different plugins for Magisk. Um, there's different methods and approaches for trying to bypass that. It really all comes down to just simplifying it, but looking for things on the device, looking for indicators that would show that we did something to jailbreak it, like binaries that shouldn't be there, permissions in the file system that shouldn't normally be, read write when they should be read only. So just the more you kind of know about that stuff, the more knowledge you have for getting around that. Using off-the-shelf tools is definitely the easiest way. We don't like to spend all of our engagement fighting with that though, because it is just one control, and we're usually trying to focus on looking at the application as a whole, the API calls it's making, and just kind of evaluating the overall security. But we will look at that. We will use magics on some of those things if we really have to. We try to ask that clients will provide applications without that, but we know that sometimes they don't have control, or sometimes it's a third-party developer and they're not able to get that removed. So when we really have to, we can also drop down and use something like Frida scripting, where we can hook different API calls. So like at the, say, file access layer, when the application is trying to look for certain files and it's finding files that are related to jailbreak, like the SU binary, we can look for that. And then when we see that come in, and then again, this is a very simplified example, but just as an example, we'll look for those API calls, see that come back, and then you kind of lie about the result. So that way the application is unaware of the jailbreak there. Very similar on the iOS side, there's a handful of tools. Liberty Light was one that we used a lot. Some of the newer jailbreaks kind of take care of some of that stuff. Included, there's a tool that I wrote that was kind of basically just like Liberty Light, but iHide, which I did that just so I would have kind of a source code to add things on when Liberty Light wasn't working for me. So there's a bunch of different things that we used, and that's always a moving target as well as the jailbreak scene continues to move forward, and the techniques and stuff change on that.
I would definitely say start simple though. Try things like objection first, Magisk, then start things like iHide and Liberty Light, and then once you run out of all the kind of off-the-shelf tools that are, and there's a whole collection of free scripts published on their webpage that have some scripts for this. Once you've exhausted all that, maybe it's time to either talk to the client about getting a build that doesn't have that detection, or do they want you to spend the time writing custom free scripts that are going to bypass whatever their flavor of root or jailbreak detection is. So
most of those tools work off of a collection of things that they've seen and used before, right? So they just try to generically bypass looking for this file, or the Cydia URL scheme. Like if you see that, don't let that work. So they try to do it generically, but sometimes we can cheat a little bit. So depending on how the application was written, we might really just be lucky and there's a whole bunch of checks, but it all ends up being in one function that returns a Boolean true or false. So once we find a couple checks and we kind of step up in the code a little bit, we might see that main function where we can just change it. It's going to be very specific to that application, but sometimes that's another way that we'll deal with it as well.
Looks like we have quite a bit of questions queuing up. I think we kind of spent a little time on one of the questions says how much time is spent reviewing app code versus app network traffic. And I think that one would be a good one to kind of segue onto. I guess for me personally, I think I spend more time on application traffic through Burp Suite versus not packet captures. But we do reverse engineer the application prior to testing it dynamically, as you can kind of get a high-level overview of how the application functions. I use MobSF as my first go-to when I start looking at applications. So it gives me high-level overview of permissions I might want to check, URLs that might be of question. Maybe they have hard-coded usernames and passwords in there. So let's say my engagement is about a week, I'll take the first 2 days kind of looking at the application itself and then how it functions, and then I will start doing some traffic capturing. And then I also like to capture traffic prior to logging in to see how the application runs, and then afterwards, because it might run differently when you have a user logged in. And then after that, we go to internal storage. So it's kind of hard for me to give how much time I spend on it, because you might go down one rabbit hole and you might end up spending a whole bunch of time on source code, or in the sense of if we're reverse engineering to try to bypass jailbreak detection, then you're going to spend a lot of time in the application code versus getting to the actual dynamic portion of it. So don't know if you guys have any more to add on that.
Well, on the
Yeah.
network side, sorry, Rob, you go ahead.
No, go ahead.
Well, I was about to say, sometimes we're testing a mobile application that coincides with a web application, right? And it's not uncommon for the APIs used by both the web application and the mobile app to be completely the same with no differences. And if that is the case, and we've spent already a lot of time on the back end API when we did the web application, I will often cut short a little bit of time. I mean, we're certainly going to look at all that network traffic as we can with the mobile app, but we'll spend less time on that back end if we've already looked at it, right? We'll look for if there's something different that maybe the client wasn't aware of, a different API call for the mobile. But it's really good to kind of, if you've already looked at it recently for the other app, carve out some more time for a little bit more reverse engineering or digging through the files, looking for sensitive data. So that's my take. But that's not an uncommon scenario for us to have a coinciding web app with the same API. So
Sorry, just to circle back on something real quick. I don't know if you guys can see it in the chat, but I did share two URLs that I used a lot when we're looking back on the question about devices and how we decide what to get. Like I said, it's a big moving target, but what I like to use is that ios.cfw.guide website. So you can click kind of by phone. If you look at that, you'll see the phones, iPad, iPad Air, iPad Pro. So they kind of list them all out. And I just kind of start clicking through some of those. Browse the devices. It gives you right off the front page there the latest jailbreakable version for those. So I'll just look for one that kind of meets the needs of what we'll get. And then when you click on that, you can kind of see the details about which jailbreaks work and for which version, because sometimes it depends on the version. But that's been very helpful for us because we used to try to track a lot of that ourselves, but using this website just kind of makes it easier when we're trying to go out and find new devices. But yeah, back to the question that was at hand, though. Just one thing to add to that on reviewing app code versus network traffic. I think generically, for the most part, there's a little bit of stuff looking at the app code, but it's mostly just kind of how is biometrics done if we're doing that? How are we storing credentials for applications? Because a lot of mobile apps, you log in once, you never log in again. So where are those credentials going? How is that being stored? And what kind of files are being stored? And then a lot of it ends up being the network traffic, I think, in most cases. But special case things like they were talking about, especially things that interact with hardware, especially when they're interacting over Bluetooth and NFC, then a lot of my time is spent with code. A lot of my time is spent with objection and FRIDA and doing things like trying to sniff Bluetooth. I know we can do that with like an Ubertooth, but sometimes that doesn't work that well. And trying to sniff NFC traffic with hardware, it's just easier for me to find the NFC calls in Android and then like say hook those with something like FRIDA where we can monitor those things and then also change them as they're going across the air too. So that it just comes down to again the kind of the type of app and the what we're looking for on whether or not we spend a lot of time in the code.
So we can keep on track with the capturing traffic. It looks like we have another question that says, I'm curious about capturing the outgoing and incoming cell phone or cell and network traffic. So I guess we can elaborate more on maybe methods on how we do that.
So I would say on mobile, I don't think we really look at a lot of cell traffic. When it comes to traffic, we're usually looking at it from the perspective of most applications can connect over Wi-Fi when they're going out to the internet. So we will either do proxy settings within the phone itself and then redirect that to Burp Suite. And then most of the time it's just 80 and 443, HTTP, HTTPS. Sometimes there's WebSocket traffic. Sometimes there might be other ports that we got to look at as well. Another thing we do, sometimes the applications are a little stubborn and they don't follow what's in the proxy settings. So we'll use some plugins or scripts or things like that to try to direct traffic. And then kind of another last ditch effort that we'll use is just route the entire phone over a Wi-Fi pineapple. And then Drew actually wrote a plugin for the Wi-Fi pineapple because it didn't have a nice interface to do so, but just to kind of automatically set up the IP table rules for redirecting the traffic, picking which ports you want to redirect and an IP that you want to redirect those to, so that way it's easy to kind of get traffic flowing. You could use that for other things. It doesn't necessarily just have to be HTTP traffic. So I'm assuming like if you want to do like SMTP, if it's doing something like that, you could redirect that to a tool for it too. But for the most part, for the most of the stuff we're looking at, it's mostly just like HTTP, HTTPS, WebSockets. Um, Cell stuff, I don't really see that much unless we've had maybe one or two applications that required cell service, but the traffic itself, um, the way that we'd monitor that is we have some scripts that we use. Um, I have it mostly developed for iOS, not so much for Android at the moment, and we haven't really published anything yet. Because I don't feel like it's in a good state to publish it. But we have a script that kind of captures all of the API calls on the iOS side. So basically, any API call that you can do in iOS that handles or manages network traffic and callbacks, for when we're getting the web responses, to try to capture all of that and log them out. And then maybe also log them in a nice format where we can easily copy paste them into Burp Suite for tampering. But that's one way that we deal with, an application that has to be cellular only. So we can still see the traffic. We just won't see it over the air. We'll just see it from the network API calls that are being made. But it does leave the possibility of missing some stuff that way. Let's see. Sorry, just looking through the questions here. Do we spoof GPS location and techniques for doing so? Yes, that's something we do. We don't always have to do that, but some applications will only let you say order food if you're nearby, or check in to a location only when you're close. There are, I don't know, I can't think of the names of the applications, but if you just look on the App Store, there are applications, especially on the Android side, that will let you spoof. And they work on different levels. Some of them will let you spoof just by turning on developer mode. And then there's a setting in Android called mock locations. So that's specifically for developers for testing. You can go a little deeper. There's applications that require root access, so they'll spoof it at an even deeper level. And then you could even spoof it by, again, writing custom scripts to just hook the API calls that are being made there and then feed fake location data. I think the apps that do it are a lot easier though, because if you're trying to simulate, say, walking around or moving in a path, it's a little harder to do that by writing custom scripts versus just using an application where you can kind of load up a map and a route and then just kind of play the route. But I can't remember the names of some of the ones that we've used. But honestly, it's just I'll kind of search the Play Store for the ones that are available and then use whichever one seems to work. Um, There's another question. How often do you come across outrageous vulnerabilities such as URL scheme hijacking or Android task hijacking? Um, I can think of one thing. I don't. I, so Drew, I don't know if you have anything outrageous. I'm kind of going to speak on your behalf a little bit, but I know there's like what I would call the unicorn that you always seem to be looking for, which is the web view based applications that have file access allowed with JavaScript. You know what I'm talking about?
Yep. Yep. There
I don't know
is
if you want to
a
touch on that a little bit.
there's a chain of vulnerabilities that's possible where if you have WebView in Android, it is possible to allow JavaScript to read write the file system. So a common vulnerability we see is sensitive data stored insecurely in the sandbox. Cookies, tokens, passwords, whatever it is. Um, if you found a WebView application that had that configuration, and you had a way to introduce cross-site scripting into that view, then you would be able to read those files off that has that sensitive data that's escaping the sandbox. I have never gotten all of those things chained together. I've come like within like one step once. But it is possible. I'd love to see it someday. It's something I'm always looking for, but I haven't seen it
I
yet.
think, yeah, between that and like intents, being able to send a message to an application that has a broadcast receiver and listens to those um, and does something. So if you're not aware what those are, but intents are like messages, like inter-process communication where apps can communicate. So the apps are sandboxed. The data within the directory should be sandboxed, so one app shouldn't be able to see the data of another. And unfortunately, I guess fortunately for our clients, but unfortunately for us, we always look for that kind of stuff. And I don't know that we've ever ran into it in the wild sometimes, but just being able to see an application where, by sending a message to it, you might be able to get the application to read something out of its data directory or get information out of there. But that's something that we look for a lot too. Um, but yeah, those are probably, I think, some of the more, I guess, cooler mobile specific client side specific things that would be neat if we would see those. But we don't really see that a lot.
Looks like
Um,
there's a couple more that are touching on vulnerabilities. So one question was what has been the most interesting or unusual vulnerability and if any of you have discovered in a mobile app?
Mm. I guess so. The one of the more interesting things that I see from mobile apps is not so. I guess it's not so much our common ones, but it's the ones where we have hardware involved with it as well. Those are the more interesting to me, where the application is communicating either over Bluetooth or NFC. Um, so honestly, just either I don't know, finding things that I think the NFC stuff is probably the more interesting one I've seen. Can't really speak on exactly what it is, but just watching the NFC traffic from an application to a device and seeing how it's kind of communicating and maybe generating security challenge responses and things like that, and just trying to figure out that whole protocol. I would say that has been one of the more interesting things that I've seen or looked at, just because I had a lot of fun digging into the source code, digging into the app, and then trying to uh, change the application's behavior through free descripting to tamper with the NFC or do like fuzzing. But that kind of gets a little bit more into the hardware side of it, though. But that's kind of the jumping off point was using the mobile app and having that starting point of watching its NFC traffic.
Yeah. And haven't you cheated on tests before? So there's
We
test cheating.
Drew has. I have, but not from the mobile side.
So those are like fun.
Drew, I
Or
think one of you two.
like the blended, so when we're doing mobile engagements, like you had touched earlier, um, it is kind of a blend between a gray box, but I know I had found that integer overflow that get me free sandwiches if I ordered over X amount. So it just kind of depends depends on how the audit goes or the engagement.
Yeah, I won't go into any details on test cheating, but I think probably the most devastating vulnerabilities we find are on the back end, right? The iOS and Android, you can make all sorts of coding mistakes. Just the nature of the platform is going to minimize the impact, except on the back end. As long as you get your back end okay, you can make a lot of mistakes on the client side, and you're generally going to be protected from devastating impact. It's pretty rare to see something above a medium severity finding on a mobile application test unless it involves the back end. And we've seen some pretty devastating back end vulns. I mean, particularly with an API that is mobile specific, because web application developers often know, like, look, we can't trust inputs if they've made an API specifically to serve the mobile applications, the developers may not be thinking quite so much in that direction because it is so much harder to manipulate those inputs versus a web application. But we can still do it, right? Once we have to get in the right place, we have to be able to proxy traffic or get our free scripts in there, but we can still do it with a lot more effort. So sometimes developers skip some of those checks and trust those inputs a little bit more, and they can get into an awful lot of trouble there.
So I guess keeping on track with that, looks like we had another question that said, what are the most common vulnerabilities that you would find in a client's project while static testing? So I know for me, mine would probably be the ATS settings, I believe, and then use clear text protocols. So those are the ones that I see the most. Drew, do you have any that stick out to you?
Hard-coded secrets. We'll see that static testing. Honestly, I think you're going to get your best findings out of dynamic testing. Static is only going to take you so far, but it's a
And
great start.
local data storage, right? Those
Yeah, but you have to use
that
the
cache
app
DB.
first.
Yeah.
You have to
Yeah, I
work
would
with the
say you could call it static testing. I really see it from dynamic testing, but just, not using the security features that are already built into the platform and trying to roll them yourself. So not using the keychain and the key store, or using them but not using them correctly. Same thing with biometrics. I know Drew has recently seen some where rather than having secrets tied to the biometrics, where the proper way is if you set that up right, the biometrics are required to access the secret. It's kind of like, say, part of the encryption key, if you will. So without the biometric, there is no getting the data back. If the biometrics are wiped, the data is wiped or it's not accessible anymore. But kind of say maybe implementing that in a way to where instead of tying it to that, you might just say, if biometrics check out, then access this data. but you can still access the data without the biometrics because it's there. So, sometimes we see things like that. So just kind of misconfigurations. But I would say we see that sometimes from the static side. And I say static more like, I guess, from the client side. You can see it from the static side, but we usually see it just testing dynamically is where we see that stuff.
Yeah, we did actually find that in source code review, but we noticed it first dynamically. Start up the app, and before you've even scanned your fingerprint, we see the decryption key is pulled out of the key store and it's flying around and it's
Yep.
used, and then plain text passwords were pulled out of the encrypted database all before you've authenticated with your fingerprint. And that was the ordering issue. We could have found that with source, and we did find it with source code review, but we found it much faster. It was much more obvious with that dynamic testing.
I will say, I guess some interesting ones that I've seen. One from static review has actually been, um, we'll just say it's a place where you can kind of go, you can play games and use cards to do that. And a test card was found inside of that um, that has credits on it. So that's kind of an interesting one that I've seen in the past. And another one has been, these are more just, I guess, fun things. I don't know that it's necessarily um, it's kind of a little bit from static review, but another one that was interesting was, say, a movie theater chain where you could get a free snack on your first time by signing up for that like movie club thing. But if you didn't actually log in, they would tie it to your device ID. So just by randomizing the device ID every time, you could always generate free coupons for free stuff. That's kind of the thing that I think is the most fun, which is looking for free things and stealing stuff. But that was kind of one, not like the craziest vulnerability in the world, but just they didn't really think through what would happen if somebody were to just change that. And it wasn't really too big of a deal for them either, but just those kind of things I think are kind of interesting too sometimes. You guys have any questions off of the list here that you want to jump into? I think we're still, Patrick, are we still good on time?
Yep, still good on time.
I did see one up there from Ian about Flutter and React apps. So like the implications. I'm gonna be honest, I rarely see Flutter apps. Certainly see a lot of React Native. Generally, it's easier to reverse React Native, although you often get a bunch of really obfuscated JavaScript. And I read and write a ton of JavaScript, and even once you kind of have beautified that as best you can, it's still really hard to follow that logic unless you're looking for something very, very specific in the code. But you'll see Hermes optimizations. I think Hermes was a Facebook maybe or Meta, but that it wasn't intended as an obfuscation tool. But in practice, it becomes pretty obfuscated. So it just makes them harder to reverse, honestly. But I do like from the developer's perspective that you have like one kind of code base to target both, just from a management of the project. There's so many great third-party platforms where you can kind of write once and run on iOS and Android. I think that's something really most people should be looking at, just so you don't have to manage two different code bases. Don't just think about your pen testers of what's fun for us to hack. That's a pretty good approach from a dev perspective. But some of those third-party platforms does complicate our lives. So
I really like that question. So, the one thing in terms of what are the security implications of it, I think first off, if you're not using those and you're writing native code, you have similar security features between the platforms, but the code is totally different on how you implement those. And we often see things where the keychain is used in one and file storage is used in the other. So they're not just totally not even using the security feature of another platform. Or one application might implement biometrics and the other one didn't. And there's two different teams writing the code. So the code bases are totally different and how they implemented things are totally different. So while the application looks the same, it really is developed by two different people. So for the most part, I think it's probably good for security that the code is written in one place because it's consistent. So if you're going to use, storage, secure storage, you're not directly accessing the secure storage. You're using the frameworks feature, and then the framework under the hood, when it gets compiled, is going to determine how it's going to either use it on iOS or Android. So for the most part, it should be keeping things consistent and making sure, again, if you the whole write once run anywhere kind of thing, you do it one time and it'll be consistent between both. The only downside that I think there is to that from the from the developer side is just that if you need to do something it might not be exposed to you through the framework. So there might be times where you run into something where you're trying to do something a little bit better and you just can't find the right way to do it through that framework, or maybe it's just not exposed to you. I can't think of anything specifically on that, but that's, I guess, something that could be a potential downside. But for the most part, I do think it's nice. From the testing perspective, though, like Drew said, it definitely can complicate things, because now instead of looking at reverse engineering just like Objective-C or Java code, now we have different frameworks that have their own bytecode. So Hermes for React Native, getting compiled into its own bytecode, and then there's bytecode decompilers for that. And we can't keep up with all of that stuff, so we're not going to be an expert on every single one of those frameworks and what all the bytecode looks like. That requires a lot of time, like looking at the engines to see like how that stuff works. So usually that becomes somebody's project where they really like to dig into that stuff and they keep that tool updated. But if that person is not keeping the tool up to date and we run into, say, the latest version of React with Hermes, then we're just kind of dead on the water sometimes on trying to reverse engineer what's actually happening in that, unless we want to spend a ton of time trying to update the tools. So really that just comes down to, now we're looking at dynamic analysis and trying to hook things, because it does at some point, it's calling the underlying framework stuff. So we can still try to do that shotgun approach of hooking a bunch of interesting things like encryption calls on the underlying framework and see if we're catching anything that way of interest when we're looking at those. But I would say my absolute favorite reason that this was brought up is because I really enjoy looking at the Xamarin and Unity stuff, which is all .NET DLLs. And if you're familiar with .NET, a lot of times those DLLs are very easy to reverse engineer using something like dnspy. So you're basically just reading the C# code. It's not like you don't have to look at the low level or the bytecode. So for most of the time, without any obfuscation, a lot of those apps are very easy to read the entire source code. And even more fun, dnspy and some of the other tools will even let you edit that bytecode very easily by just typing C# in. So the most interesting ones I've looked at are mobile games, where some of the logic is handled client side and maybe it's not all handled server side. So it's really fun to, say, tamper with some of the C#, recompile, put that back together, enabling debug menus and options and things like that are in there, and just kind of digging through to see what interesting stuff is in that. But that's been kind of my favorite thing that's came of that. I did see another question here. It says, I review apps for privacy concerns, mostly looking at their app traffic. If I wanted to pivot to more of the security review side of things, what advice would you have for me? I'm not a programmer, but I'm able to keep up with and understand conversations like in this webinar today. I would say a really big thing, and you guys, maybe you have more, but just, looking at the applications and just looking at the traffic for privacy concerns, that's probably a good way to start. Just, getting familiar with like getting those things loaded up. I would say if you haven't tried it yet, playing around with objection or Frida, and there are test applications through OWASP. I would say the OWASP mobile pages that they have are very good. The mobile testing guide from OWASP, that's probably a really good way to familiarize yourself with some of the stuff that we do look for and some of the things that you could start playing around with and looking at. Again, just make sure that whatever it is you're looking at, you do have permission to test. So you can look at bug bounties are always a good one to look for, or just looking at, I think OWASP has a test mobile app. There's like some mobile banking ones, just test apps that you can use. So there's a couple test mobile apps out there for playing around with. But those are really good ones. I would say using something like that and then going through the OWASP testing guide and looking at the techniques that are used in there, that's probably a good way to start practicing and moving out of just looking at the traffic, but maybe kind of playing with some of the other client side specific stuff too. Do you guys have anything to add to that?
Well, Whitney touched on it earlier with MobSF. It is
Yeah.
a fantastic tool. Also, one of the first things I start with. If you are looking at an application from a third-party perspective, I think this is a fantastic tool. There's a lot of features that aren't super relevant to what we're looking at when we're assessing a client's application, whether or not they're using too many permissions. That's really on our client. But if I was assessing an application from the perspective of, do I trust this application? MobSF is going to do a whole lot of things for you, including like pull out all the servers it talks to. It's checking those servers against a list of known bad servers. I think it even has like a pew pew map. It's kind of funny. It
Yeah.
shows all the servers it talks to. it'll lay out all the permissions that seem excessive. It's a really great quick read on, what is this app able to do and who is it talking to. So that might be and it's easy to run out of Docker. So
It also,
um,
I think, shows trackers too. So when I was
yeah.
doing my AI talk for DEF CON and I needed to pull some apps down to kind of show, these facial recognition apps like Snapchat or something, like these are the trackers that it has tagged to it. So that's another thing if you're wanting from a privacy aspect, it will show, what kind of trackers the app has, MobSF will. So you get a lot of information from the application.
Looking at the other apps made by the same developer signature might also give you some clues as to privacy concerns if they're writing other sketchy apps. Maybe that give you some hints as to what to look for in that particular app. I think there was actually a Play Store, a separate third-party store that would kind of link all those together. I can't remember what it was. Um, Show you all the other apps with the same signature. What was that?
You guys good for another question? All right, sorry. So yeah, I saw this question. So lots of talk on Frida. That usually implies Corellium in iOS 16.5-ish or plus or minus a little. But Frida is easily defeated and doesn't work on later versions of iOS. Are you mostly focused on Android then? So I will say I have an iPad with iOS 17, whatever the latest 17 is, beside me right now that is jailbroken and has Frida installed on it. So it definitely works on later versions. And it can definitely work on later versions through Corellium too, including up to the latest version. Um, so we still do use that a lot on iOS, not just Android. Um, and really, again, the tools that we use, it really just comes down to what we're trying to do and accomplish. A lot of times, the applications we're using, maybe you can defeat Frida, but it's a client side thing. Like if we have full root access on the device, and you're trying to determine if Frida is there, it's kind of like a cat and mouse game, and it can just get harder and harder to the point to where it's just not worth the effort to try to get around that kind of stuff. So that's definitely a thing. But I think we really only see that in applications that the intent is to prevent a lot of that stuff for good security reason, like MDMs or things like that. So we don't really see that a lot in an application where they're trying to prevent Frida from working. I have seen it. We've seen it in things like Intune or things like that, where maybe they have a couple specific checks in there, but we don't run into that a lot. So for us, for regular off-the-shelf applications that most consumers would be using, um, just kind of like everyday apps and things like that, I don't see that a lot. Um, it For me, that seems to be mostly just kind of around MDMs or mobile games that seem to tighten up the security a lot just to prevent cheating. Do you guys have anything to add on to that?
I don't think I've ever had an app that was outright blocking Frida, and I've been able to run it even on 17 with no problems. If I'm unable to do Frida server, it's because they've got some kind of root jailbreak detection that I haven't been able to bypass. And then I can still do the gadget and then sideload. So it hasn't really been much of an issue. So, but there are tools out there to help, actively block Frida. It's just not widely used.
And when Drew says the gadget thing, so just to talk on that a little bit, most of the time we test on a jailbroken device, but sometimes we might require, say, iOS 18. One of the techniques we'll still use to do testing is if we can't jailbreak that, if the application is going to be provided to us not from, say, the iOS, the Apple Store, but the IPA can be provided to us directly where we can sideload it. We can patch what's called a free to gadget. It's kind of like on Windows terms, it's like putting a DLL in there. Basically, a shared library gets injected into the application, and then when the application is launched, the Frida shared library is launched too. So we still have kind of the full access we need. We just don't have full access to the entire phone, but we can still look at all of the API calls going on within the application, look at its data directory, look at its keychain or key store. So that's one technique that we use. And that one, it can be a little tricky sometimes because patching the application, sometimes the patching process doesn't go well or the application doesn't work and we have to look into why. Is that a protection or is it just didn't want to be patched for whatever reason? It kind of broke something. So we don't always try to go that route. We try to save that for, like one of our last ditch effort things if we have to. But like Drew said, I don't think we've seen a lot of things really specifically trying to prevent Frida from working, or when we do, sometimes we see maybe more like rudimentary checks for stuff that are easy to get around. But we definitely ran up against stuff that has had some pretty solid, say, in general, jailbreak detection, which has required some effort to get around. And then kind of to touch on that a little bit too, somebody else says, is it safe to assume then, the same person, is it safe to assume then, is this Android centric? Are we seeing any hacking or related activities into iOS 18? Sorry, I'm still kind of getting over being sick a little bit, so apologize for that. So yeah, again, it's not Android centric what we're seeing. I think when we kind of first got into some of this stuff, it definitely was easier to do things on Android. It still is easier for us to do stuff on Android just because it's easier to get access to the devices. They're easier to root them. Um, the Apple ecosystem is a little bit more locked down. Research into the kernel and things like that's a little bit harder to do. Um, and it becomes difficult to get the devices and things like that in the environment set up to test on. Um, so as far as, are we seeing anything into that? Us personally, no, we don't really follow that kind of stuff in terms of we're not looking at it from the kernel level or we're not looking at it from the platform security. We're mostly focused on kind of doing app testing. There's other people out there way smarter than I am that will look at that kind of stuff and come out with the jailbreaks. So we just kind of try to keep up with the trends on those, and you just kind of follow the jailbreak scene and what's going on there. And then just try to get ahead of some of that stuff in terms of making sure we have our devices and understanding whatever the latest like tools are going to be moving to and how they're going to be dealing with that kind of stuff. So we can kind of, make sure that we're prepared as the new versions come out. But yeah, I mean, it always seems like that. Every now and then there's always an iOS version that comes out where everyone's like, hey, it's dead. There's not going to be jailbreak for a while. But we've really been kind of riding on the checkmate vulnerability for a good bit where we've got devices where we can still kind of get up to the latest version. And then again, like I said, Corellium being another option that we've used where we can kind of get a latest jailbreak or just side loading and patching things for dealing with it from that perspective as well. We have a few more minutes here. Another question. Do you wish more developers knew about mobile security? Yes. I would say, yeah, I mean, some people definitely put some effort into it and it's great. And some people, they just don't know what to expect. So they throw the app over and they're really just hoping to learn from that and then see what they get out of that. Um, so
Or also, too, if you are given both Android and iOS to test, sometimes one application is more secure than the other. So it kind of just depends on who developed it. Sometimes they outsource their Android and iOS to separate developers, so you get two completely different products.
yeah, that's something that we see a lot. So it's not even so much that the company that owns the application is not kind of like up with security, but it's more that they don't even have, say, a development team that can do mobile, so they have to farm that out
Mhm.
to a third party. And then so that kind of complicates things because they're kind of like a middleman between doing the security assessment and then trying to get the app developers to implement security and take that seriously. So they kind of use the app test to put back on the development team um, to try to push for certain things to get fixed or changed or done in a certain way. Um, but that can definitely complicate things sometimes. I did see there's a question that was interesting to me, but I'm not entirely sure um, what the question is. I don't know if you can clarify it. Well, we have a couple minutes here and we can try to answer it. But as a bin-to-bin virtualization tech company, how would you handle fully virtualized, meaning we won't use native ARM instructions? So when you say that, are you meaning things like running compiled bytecode? You know, like the Hermes stuff? Or are you meaning something else? I don't know if you can clarify on that. Okay, so our text virtualized from x86 or ARM to other op codes. Um, yeah, I don't know that we've seen that a lot in terms of the mobile applications that we've looked at, but I think the closest thing I can really relate to on that is when we, a lot of times when we want to reverse engineer and see what's going on, um, if it's written in Java or Kotlin or something like that, it's easy for us to say decompile and look at that. And I think probably the closest I can say that we've been to something like this is when, again, looking at something like Hermes, where it is some kind of a bytecode that's ran through an engine. And the way that, in general, the way to deal with things like that is having to look at the engine that's consuming the bytecode and having a good understanding of what's going on there before we even have a chance to pull apart the bytecode to figure out what's actually going on in the lower level code. So I imagine it might be something similar to that, where it's probably going to be very difficult. So the execution goes through a virtual machine. There's no decompile. It's not decipherable to a debugger. Yeah, I mean, I'm assuming that's probably still similar to like the Hermes situation though, where it is the virtual machine is like an engine reading kind of the bytecode, right? But I mean, for something like that, and I've seen that in like say native Windows applications or whatever, where it's like virtualized code is like a obfuscation or a protection, right? Those are definitely difficult, and I will say they suck, and I hate looking at those. It's just, I mean, it's very time consuming, and we just don't have the time to do something like that on an engagement, unless the engagement is how secure is this or how difficult is that. And we've done engagements like that before, but we always try to explain like you're paying us by the week to look at this, so we can look at this as long as you want. If you feel it's worth a large sum of money for us to take a look, just to come back and say this is very difficult, or this was very easy to get around. We can do those kind of things, but I think for something like that, it makes the best sense to say maybe we spend like when we're focused on security controls like that, if that's what that is, we usually try to say focus like maybe a week or two on something like that just to kind of get surface level understanding or idea of what's going on, and then kind of give some feedback as to, was this very difficult to get around, or are we making some progress? Um, so yeah, I think that's looking like we're kind of running up on our time here. So definitely want to thank everyone for coming. Appreciate all the questions. Um, if you have any additional questions, Patrick, I don't know if there's a way to kind of maybe shoot more questions over to us, or maybe kind of maybe reach out to the sales team here if they want to talk about anything like that. But I'm going to go ahead and kick it back over to Patrick. And thank you everyone for your time.
Yeah, if you guys have any other questions, related to any of the topics that we talked about today, please feel free to send an email directly to the marketing team, marketing@trustedsec.com, and then we can push those over to whoever we need to get them over to. With that, like Rob said, thank you for joining us today. Thank you for the panel for hosting, and I hope everybody has a great day.